You know, we're always hearing about how AI is changing the world, and it is. But what happens when the systems we trust with our most critical decisions, well, what happens when they get it wrong? Today, we're going to dive into how to manage the massive risks of high-stakes machine learning.
Okay, so the foundation for this whole conversation really comes down to this one simple, powerful idea from the statistician George Box. All models are wrong, but some are useful. This is the absolute starting point for any serious talk about AI. It means we have to accept right from the get-go that no model is ever going to be perfect. And that's the first step to actually managing its risks. But here's the pivot. This is the big question. When we're talking about a movie recommendation, wrong is, a minor annoyance. Who cares? But when we're talking about healthcare, or getting a loan, or the justice system, wrong can have devastating, life-altering consequences for real people. So what happens then?
To really get to the bottom of this, here's our game plan. First, we'll define what we mean by the danger zone of AI. Then, we'll look at the tricky reasons these models fail out in the real world. After that, we'll unpack a practical toolkit for building safer AI. And finally, we'll talk about the huge mindset shift that has to happen to make any of this work.
So let's start by defining that danger zone. What actually makes an AI application high risk? Look, we're not talking about your photo app suggesting a tag for your friend. We're talking about automated systems that are woven so deeply into the fabric of our society that when they fail, the consequences are profound.
The core idea is this. When a machine learning system is making high-impact decisions, a failure isn't just some small bug. It's not a glitch you can patch later. It can mean that a small group of engineers, with one flawed model, can cause real, widespread harm to countless people, all at the same time. The scale is what's terrifying.
And this isn't just some abstract idea. Regulators, like the European Union, are already putting definitions on these danger zones. We're talking about AI used for things like biometric identification, managing our power grids, screening your job application, deciding if you get a loan, and even in really sensitive areas like law enforcement and immigration. These are the systems where mistakes matter the most.
So why do these systems fail? It's usually not because of some simple coding error. Oh no, the reasons are much, much deeper and way more complex than that. So let's get into the actual anatomy of these failures.
One of the core concepts you got to understand is something called the Rashomon effect. It's named after a famous film where different witnesses give totally conflicting but equally plausible accounts of the same crime. In AI, it means you can train a whole bunch of different models on the exact same data, and they all look equally good on paper. They all pass the tests. But then, when you release them into the wild, they can behave in wildly different, totally unpredictable ways.
And that effect leads you right into this incredibly dangerous trap called underspecification. This is where you build a model that looks amazing in the lab. It aces all your tests, gets A+ grades, but the second it hits the messy, unpredictable real world, it just flops. Its performance completely falls off a cliff because that clean, tidy test environment was never a perfect mirror of reality.
Okay, so the problem is pretty clear, right? It's kind of scary, but how do we fix it? The good news is there are concrete strategies. We can think of them as a responsible AI toolkit with 3 essential tools for building safer, more reliable systems.
So what's in the toolkit? First, we need a magnifying glass so we can actually see inside the model. Second, we need a stress test to find its breaking points before it gets out the door. And third, we need a fairness compass to make sure it's not causing unintended harm or bias. Let's break down each one.
All right, tool number 1, the magnifying glass. This is all about explainability. For way too long, we've just kind of accepted these black box models, where we put data in, a decision comes out, but we have absolutely no idea why. In high-stakes situations, that is just not good enough. We have to be able to understand and, more importantly, justify how a model reaches its conclusions.
So how do we do that? Well, you can build explainability in from the very beginning by using simpler, more understandable inputs, by choosing models that have more predictable linear behavior, by letting human experts, people who actually know the field, inject their knowledge into the model's logic. And this last one is absolutely crucial. We have to give people a real way to appeal a decision if the AI gets it wrong.
Let's move on to our second tool, the stress test. This is all about being proactive. Think of it like a crash test for a car. Instead of just waiting for your system to fail out in the wild, you need to aggressively hunt for bugs, weaknesses, and failure points before it's ever deployed. You have to try and break it yourself first.
And there are systematic ways to do this. Sensitivity analysis is basically poking and prodding the model's inputs to see if it gets jumpy or unstable. Residual analysis is a really cool trick. You literally build a second model whose only job is to predict the errors of the first one. That shows you all its blind spots. And finally, using benchmark models means you always have a simpler, more trusted system to compare your complex new model against, like a reality check.
Our final tool is the Fairness Compass. And this is where we get into the critical ethical dimension. AI models learn from data. And if that data reflects our own society's historical biases and prejudices, well, the AI is going to learn them, and it might even amplify them. This tool is all about actively looking for that and correcting for it.
You know, this isn't just one problem. It's a whole spectrum of potential harms. A model can cause harm through denigration, think of an offensive chatbot, or through stereotyping, by linking a certain group with negative traits. It can cause harm through erasure, by hiding important history, or through things like misrecognition and direct economic harms, like an algorithm that only shows better job opportunities to men. We have to be looking for all of these.
So we have the tools. We have the magnifying glass, the stress test, the Fairness Compass. But tools are totally useless without the right culture and the right mindset to use them. And that brings us to our final and maybe the most important point of all. We have to move beyond that old Silicon Valley ethos.
Yeah, the tech industry's famous mantra, move fast and break things. It sounds exciting. Maybe it works for a social media app. But when AI is involved in people's lives and their livelihoods, the things that get broken aren't just lines of code. The things that get broken are people's opportunities, their finances, their well-being, their lives.
So, here it is. The real solution isn't just more sophisticated algorithms or better debugging tools. It is a fundamental cultural shift. It's about moving away from a world where success is just measured by how many new features you can ship, to one where success is defined by how well you understand and protect against the downstream risks of your work. Which leaves us with this one final, powerful question to think about. For a long time, a lot of machine learning has felt like a big science experiment, right? Just pushing the boundaries of what's possible inside a lab. But as these systems move out into the real world, the question changes completely. Are we still just running experiments? Or are we finally ready to accept the enormous responsibility that comes with engineering for society?